All right, so today we're going to be talking about solving a review of solving linear systems. And today we're going to be focusing on 2x2 equations. 2x2 just means you have two equations with two variables. So you have x and y, or it could be really anything. And then you have two equations. So two equations, two variables is 2x2. So we're going to go over the three methods we learned for solving 2x2 equations. One was by graphing. One was by elimination. Elimination was also called linear combination, but it's essentially adding the equations together or subtracting them. And then lastly, by substitution. So we are going to go over graphing, elimination, and substitution with just the same problem. We'll do it three different ways just to demonstrate that we can. First, since we have the graph paper right there, we're just going to graph the two equations. So the first equation we're going to graph is y equals 4x plus 1. So if I look at y equals 4x plus 1, I'll do that one in like purple. We know 4 over 1 is the slope, and 1 is the y-intercept, or the b value. So I'm going to graph the 1 right there, and then I'm going to go up 4 over 1 and just continue doing that. And then I can always subtract, like go down 4, 1, 2, 3, 4, and left 1. And then I can graph these using a straight line. So I'm graphing the first equation, given the slope and the y-intercept. Now the second equation is not in slope-intercept form. So I have 2x minus 3y equals 7. And then I'm going to solve for y. So first I'll subtract the 2x from both sides. So I have negative 3y equals negative 2x plus 7. And then I have to divide everything by negative 3. So that isn't great because notice I'm going to get a fraction for my y-intercept. So that's kind of a bummer. And so I might want to just pick some points and connect the dots. That might be a little better. So I'm going to kind of abort this because that's not going to really work. So let's say if x is 0, will y be a fraction or y be a whole number? Let's see. If I try and pick some points, I'm trying to, what if x is 2? If x is 2, I would get 2 times 2 minus 3y equals 7. So I get 4 minus 3y equals 7. Subtract 4 on both sides. Oh, this is going to work. Negative 3y equals 3. So y is negative 1. So that's cool because that one gives me a whole number for both, which will make it a little easier. Let me see what else would work. If I do, let's say if y is 2, oh, maybe that doesn't work. If y is 3, because I'm just trying to get whole numbers. So again, it's not a perfect process. If y is 3, I'd say 2x minus 3 times 3 equals 7. And I'm just going to see if this works, if this gives me whole numbers. So 2x minus 9 equals 7. Add 9 to both sides. So 2x equals 16. X is going to be 8. So 8 comma 3. Yay. Okay. So again, not perfect, but I was like, I wanted a better graph than one I had to use decimals for. So I'm going to graph the point 2, negative 1 over 2 and down 1. And I'm going to graph the point 8 comma 3. Oh man, I'm going to be like way off the page there. Let's see. Maybe if I could pick maybe negative 3, I could try another one. If I pick y as negative 3, I'd have 2x. That's going to be a really high. How about -1? Just trying to pick values that'll be on the graph. So 2x equals, or I'm sorry, 2x minus 3 times -1 equals 7. Picking -1 for y. So 2x plus 3 equals 7. Ooh, this is going to be a nice one. 2x would equal 4 by subtracting 3 on both sides. Divide by 2, x is 2. So 2 comma -1. Oh my gosh, it was the same freaking point. Did you see what I did there?
Yeah.
Oh my gosh.
Wow.
What? Okay.
I was gonna say something.
You know what? Apparently it's not my day here. So what I'm going to do, yeah, I need to go to another point. Let's say x is, would x is -1 work? Nope. X is -2, -3, -4. I'm going to get it. That's so funny. 8 comma 3. 1, 2, 3, 4. Let's do, man. Okay, let's try -2 for y. So we'd have 2x plus 6 equal, let's go with this. Yeah, but the fraction's a little easier. It's just 1/2. So let's do that. 1/2 comma -2. And then we're going to connect the dots. Wow, that was a struggle. Oh, I think I can see. So you can see that the graphing isn't always the best choice. But where is the solution going to be located? Yeah, where they intersect. So right there, I can see my 2 lines intersecting. So that is awesome. So that is the point -1, -3. So again, to graph 2 equations, again, not a great one to graph because we could see we got these fractions and I was worried about the accuracy. So I just started picking points, which was kind of a hit or miss method. But I graphed both the lines, and where the lines intersect is my solution. And I got -1, -3. And so that would be my solution. So you can write your answer as an ordered pair, -1, -3, or you could write it as x equals -1, y equals -3. So that's solving by graphing. Sometimes it works real well. Sometimes it doesn't work as well, but what is important either way, if it's working well or not, is having graph paper so that you can get a really good grid there to read the solution off of. So that is one method for solving systems with 2 equations and 2 variables is graphing. Let's talk about solving by elimination. So I'm just going to go to a new page. Can you read me the equations again, please?
Y equals 4x plus 1.
Mm-hmm.
2x minus 3y plus 1.
Okay, so now we're going to go over the elimination method of solving. The elimination method is a method where your goal is eliminating one of the variables. Your first step really is you want to set up 2 equations where the x's and y's are lined up vertically. You can tell with the first equation they aren't lined up vertically. So what I'm going to do is subtract 4x on both sides. So I get all the x's and y's on one side. So I get -4x plus y equals 1. And then if I recopy the second equation, we can see our x's are aligned, our y's are aligned, our equal signs are aligned, and then our constant terms, which just are regular numbers, are lined up as well. Now, elimination involves you either adding the equations together or subtracting them. If I add or subtract those equations, do any of the variables eliminate? Yeah, if you add, do the x's eliminate or the y's eliminate? Do they cancel? So negative 4x plus 2x. Right, so those don't eliminate. Do the y's? No. So if you can't naturally eliminate by adding or subtracting them, you might have to multiply one or both equations by a quantity that allows you to have coefficients that are opposites. Because if the coefficients are opposites, then when you add them together, one will cancel out. So what equation would you want to multiply by how much? Okay, and what would you want to multiply that by? Okay, so if we take the top equation and multiply it by 3, let's see what happens. We get negative 12x plus 3y equals 3. And just a reminder, you have to multiply all 3 of these terms by 3, even what's on the right of the equal sign. Now I'm going to recopy my bottom equation. Now you look, if I add these together, do any of my variables eliminate? Yep, so if we add these together, we will have an elimination. The x values are going to be negative 10x, adding those. The y values eliminate, yay. So I've kind of made my method true. And then it equals 10. And so the crux of the elimination method is you are trying to make it so you only have one equation with one variable so you can actually solve. So here I can solve for x. What would x be? Great. X is negative 1. So there I get one part of my equation. Now to solve, you can plug x equals negative 1 into any of these equations and solve for y. Doesn't matter which one it is. It can be one you manipulated, it could be one you multiplied by, or it could be an original one. Personally, I find this one to be the easiest to find y with. So I'm going to plug x equals negative 1 into that equation. So y equals 4, but I know x is negative 1, so I'm going to plug that in. 4 times negative 1 plus 1. So y is going to be negative 3. So then I can write my answers just as they are now, or I can write them as an ordered pair. And you'll notice that that answer agrees with what we got on the last page. So that means we're, doing something right. It agrees, but it's a totally different method. Notice we didn't look at the graph at all. We had to manipulate one of the equations, so the x's and the y's and the equals and the constant terms lined up. We had to multiply to get something to eliminate by adding, and then we got it. All right, let's talk about now substitution. Okay. So here is my original system. Let me just clean it up a skosh. Okay, so there's my original system. And if we consider solving by substitution, substitution means we're going to substitute one expression in for one variable. So the first step is always to solve for a variable. I really like substitution for this particular system because I already have a variable solved for. Y is already solved for. And then you substitute into the other equation. That's basically it. Everything else will fall into place. So in other words, this is what y equals. Y equals 4x plus 1. So then in my other equation, instead of writing y, I'm going to write 4x plus 1 in place of y. So what that looks like is 2x minus 3, parenthesis, what y equals. So what y equals is that 4x plus 1, and then that equals 7. So notice I rewrote that equation, but I substituted in 4x plus 1 for y. And now you've accomplished the same goal we accomplished last time, which was writing one equation with one variable, which is solvable. So what would you do first to solve? Yep. So we get 2x minus 12x minus 3 equals 7. And I get that by distributing the negative 3 to the 4 and the negative 3 to the 1. Then I need to combine like terms. So 2x minus 12x is negative 10x. Add 3 to both sides. And then divide by negative 10. And x equals negative 1. And then once you have x, you can find y. I like, again, the equation y equals 4x plus 1. We're just going to plug in negative 1 for x. Okay, so again, we get y comma x, if we want to write it as an ordered pair, is negative 1, negative 3. So we highlighted 3 methods of solving. Solving by graphing, which is good sometimes. It didn't work out so well for us that time. Solving by elimination and solving by substitution. So for your assignment tonight, you're going to have to do all 3 methods at least once, but it'll be your choice what method you want to use on any given problem. All right, so yeah, that is it for today, and tomorrow we'll talk about 3 by 3 systems, 3 variables in 3 equations.